We're going to talk today about composing trig and inverse trig functions. This is a bit of Unit 4 content. So, first we're going to draw a triangle using the inner function. And what I mean by that is we're going to be looking at things like the sine of arc cosine of, say, 4/5. So we'll use this inner function, arc cosine of 4/5, to draw a triangle using some angle 4 and 5. Calculate the missing side length using the Pythagorean theorem, and then write the answer using the outer function. So sine is opposite over adjacent. So our final answer would be 3/5. So draw a triangle, Pythagorean theorem, and then use the outer function. So let's draw a triangle. I can draw nice triangles. So there's going to be my triangle. Here's going to be my angle. So opposite will be square root of 91. And hypotenuse will be 10. Then find the missing side length using the Pythagorean theorem. So 10 squared equals square root of 91 squared plus the adjacent squared. So we have 100 minus 91 equals a squared equals 9, and a equals 3. So when we're looking at tangent, we're going to do opposite over adjacent, which is square root of 91 over 3. Next, we're going to use this one, draw the triangle. I didn't draw the fancy triangle. Secant, we're going to use the inside triangle. Secant is hypotenuse over adjacent. Hypotenuse over adjacent. Pythagorean theorem says 4, and then cosine says 3 over 5. In that particular case, we didn't actually need to do 4 because cosine and secant are reciprocal functions, but most of the time you'll need to do the Pythagorean theorem. Okay, square root of 2 as our secant, so our hypotenuse will be square root of 2, and our adjacent side will be 1. That's hypotenuse over adjacent is secant. Then use Pythagorean theorem to find that their missing side length is 1. And then cotangent would be adjacent over hypotenuse, so 1 is our answer. Here we have adjacent over hypotenuse is 5 over 12. Pythagorean theorem says 13. And cosine says adjacent over hypotenuse, so 5/13. Secant is adjacent over, no, it's not. It's hypotenuse over adjacent. So this should be 2 squared root of 55 over 11. Pythagorean theorem, I'm going to need to do this one out. 11 squared plus b squared equals 2 squared root of 55 squared. So that's 121 plus b squared equals 55 times 4. 55 times 4 is 220. Subtract 121, and we get 99. So b equals square root of 99, or 3 square roots of 11. So now, what are we asking for? Sine. So that's opposite, 3 square roots of 11 over hypotenuse, 2 square roots of 55. Hopefully you recognize that that's not an acceptable final answer because of the denominator. I'm going to simplify these. I can divide two things that are both in the radical. So that gives me 3 over 2 square roots of 5. And then I rationalize it. 3 square roots of 5 over 10. That was a big problem, so let me go through it again quickly. A hypotenuse over adjacent because of secant. Pythagorean theorem gave me 3 square roots of 11. Then I divide them. I can divide what's outside and what's inside. And then I rationalize the denominator to get 3 squared of 5 over 10. Lastly, we're given cosine, and that would be adjacent over hypotenuse. And by Pythagorean theorem, that means this side is square root of 2. Tangent is opposite over adjacent, so tangent is 1.